Hi, and welcome to Maths Appeal. My name is Bobby Seagull.
And I'm Susan Okereke.
And we are two maths teachers who are really trying to show everyone, whether it's a parent, a teacher, or a student, that maths is something that can be enjoyed by everyone.
Yeah, and we want to demystify the idea that it's boring and it's irrelevant to people's lives. And we want to kind of make it more inclusive.
Absolutely. Again, the fact that you're listening shows that we are making maths a more inclusive world. And in season 2, we are trying to focus on problem solving and mathematical thinking. Obviously, in the real world, there's problem solving. You know, your sink might be dripping. You're like, oh, how do I fix that? But there's also a mathematical way of thinking about approaching problems, like a logical mindset. And we're trying to help you develop that.
And as maths teachers, we also know how difficult that can be to teach because, you know, there's a lot of content that we cover, but problem solving is a thing that you have to do. The more you do it, the better you become. But there's also loads of skills that you can learn to be able to do it well. And that's what we want to showcase as well. So a lot of people get scared about maths because they think they can't do it and the problems are too much for them. But we're here to show that everyone can. And we also sometimes make mistakes.
Yeah, absolutely. And then these are not like pretend mistakes. They're like, oh, let's make a mistake. These are genuine maths teacher mistakes. And that's part of the reason why we want to show that maths is an activity that can be done together. Because when you actually do it together, it's much more powerful. Then you're like, oh, Suze, you made that mistake. Oh, Bobby, what's that? Where do you get that divide sign from? So it's really like almost like a joyous collaborative activity.
We'd also love to help you with your skills, but also find out more about what problems you'd like us to solve. And we would love you to tweet us at mathsappeal or email us at mathsappeal1, the number 1, at gmail.com. If there's any maths problems you want us to kind of tackle, or if there's any maths topics you want us to talk about.
Perfect. And every episode, obviously, we will feature a maths question and we will work through it together and hopefully make you feel not just more comfortable with that particular problem, but about developing your approach to mathematical problem solving in general.
And so what we kind of do with this podcast is to have a few key questions that we recommend you ask yourselves, which we will ask ourselves openly. We'll model them for you, I suppose. And generally what we ask before we start the problem, once it's been kind of said, we ask ourselves, how do we feel when we first saw and heard the problem? So emotionally, what's going on within us? Then we think, right, does this problem make sense? Are there any questions I have or any assumptions I have to make about it? Because that's, as mathematicians, that's what happens, what you do. Mm-hmm. And then also we think about what are the maths topic in this problem. So before we start doing any maths, we're thinking, what does this problem start to fire up in our minds regarding mathematics?
Exactly. And then when you're doing the problem, there'll be other things going through your head. Like firstly, what are the facts that you know, like in a classic exam style, underlining the question. Then secondly, like, what are the rules and formulae that you need? So this might be using your exam booklet if you're a student, or if you're a real person, like, pi r squared area of a circle, drawing something from your memory. Then the facts that you can derive from the problem itself. And then finally, like, am I in a position that I can actually answer this question?
Right. So, Bobby, are you ready to tackle this week's problem?
Yeah, I think so. I think I'm ready.
So we're going to get into it just after this.
So our problem today is this. So this is drawn from a set of GCSE type questions and adapted to give you a more fun context. So there is a basketball team and we have some stats on the shoe sizes of the 5 players. And we're told for the 5 players and their shoe sizes, the mode is 12, the median is 11, the mean is 10. So you need to work out what the shoe sizes could be. So I'll repeat the problem one more time for you. So there's a basketball team with 5 players with 5 different shoe sizes. And you're told this sort of 3 bits of information. You're told that the mode, so the most common, is 12. The median is 11. And the mean is 10. So what are the possible shoe sizes?
And so while you're thinking about that, we want to have a little bit of a chat about maths in films, because we both love films, so we kind of want to talk a bit about that.
So I think for us, seeing depictions of mathematicians, scientists in films is something that I don't know, I guess it means something to us because it's almost like, here are people like us, like obviously like super advanced versions, but here are people like us on screen.
Yeah, I mean, it's funny because I think my thing, because you're right, like, I think it is amazing to see representation of mathematicians and scientists in film. But, like, when I think about film, and especially when I was growing up, it's all about popular culture. Like, was born in the 80s, and, there were cool films like The Goonies,
Oh my
or,
god.
just stuff that really, set apart, like, I felt like I lived in America sometimes because it was a really massive part of my life. I remember going there to Hollywood a few years ago, and it was like I knew it already. And I think one of the reasons you want to sort of talk about maths and film is because the impact of popular culture on what young people want to be and do is huge. And like I did a talk about just the importance of popular culture and the impact it has on people's choices. And I found this little YouTube video, which I'll make available when this goes out, that it says it's only 2 minutes, and in that 2 minutes it's literally called Hollywood Hates Maths, and it's just snippets from I'd say at least 50 different films where they use maths as a derogatory term, like oh you maths teacher, which is like you're not very good, or oh my god, I'm really rubbish at maths. And it's really open how people talk about how terrible they are at maths, and it's completely normal. And that's something that I just think that I really want to talk about and change. Like you said, Bob, it's really great to see people who are like us, who love maths and do science, and we'll talk a bit about some of the amazing films that are out there. But there's a lot underneath in popular culture, in film, where it's completely okay to say that you're bad at maths, and that I think is something that needs to be challenged.
Yeah, I'm going to be a bit devil's advocate here, Susan, because they're like obviously. What are some of your favorite films where they're mathematicians and characters represented? Give me some of your favorite films.
Well, a standout one for me as a black woman was Hidden Figures. Like that kind of was really quite huge for representation, and also just acknowledging the fact that, because I was a maths teacher, I stand up in front of people and I try and like say maths is for everyone. But the reality is I've not really seen many black women scientists or mathematicians. And so that film, which was so cool, just, and they were so like strong and through adversity, but also so clever. I was like, more of this, please.
Yes, no, it's a proper inspiring film. And it stars Taraji Henson as Katherine Johnson. And Katherine Johnson is one of the lead characters in that film. Just like sending, doing the calculations to get NASA. To the moon or to space? To the moon, isn't it?
I think to the moon. So it was in the 60s, yeah. And it was just, and what was great about it was it wasn't just one. There was like, a team of people who, in history had kind of been forgotten. You know what I mean? It's kind of, they don't get talked about. Or they get
I never heard about Katherine Johnson or the black female mathematicians who worked for NASA till the film came out. And we are both like, I'm a learned scholar, like I like understanding the history of my subject, but I never was aware. So clearly Hollywood can play a role in showing the best of mathematicians.
But also there's the variety of mathematicians. I think it's like with Imitation Game, Turing was a complex character, but he helped change and save the World War II. And so it was kind of to see people in their complexity as well as the math that they do. It's great stories, it's storytelling. I think talking about this is about trying to encourage more stories to be showcased in film form or in short series form on the Netflix or something, because the reality is we need more scientists, we need more maths teachers. And like young people, like if I think about being young, even being old, like watching films and TV shows that show different people, especially people that look like you, can really open your eyes to what is possible. And I think it's also, we need to challenge the idea that it's okay to say that math is rubbish, because that is terrible marketing and also not fair, because actually maths can change lives. And science and maths, the STEM industries, we need more people.
Yeah.
That's
Well,
it. Doesn't matter where you're from.
This is where I'm going to play devil's advocate here. So,
Okay, go on.
The Man in New Infinity, great film about the South Indian mathematician Srinivasa Ramanujan, acted by Dev Patel. Then we've also got Beautiful Mind, Russell Crowe, starring as the Nobel Prize-winning economist John Nash. So you've got all these films here, and Alan Turing or Katherine Johnson, or even like Good Will Hunting, the fictional account with Matt Damon. So all these are like mega super geniuses. And obviously, I love it. It's brilliant because it shows they're positive depictions of some of the leading figures and mathematicians. But most normal people who are mathematicians, math teachers, are normal people that have a passion. I would love to see more positive representation of maths teachers, in particular, whether it's in soaps and dramas, and they're not just like, oh my god, I got maths coming up. So obviously, you've got these elevated figures, but just like people like us. Like,
Are you pitching for a film, Bobby? Is that what you're trying to do? You're looking to get yourself a Netflix, series about yourself? Is that what you're trying to do?
Netflix, listen to us, maths appeal, please.
No, but I hear you though. I do think there's all the layers of it that should be showcased, and I think there is a bit of a thirst for it. I think probably 20 years ago a film like Hidden Figures wouldn't have been made because they'd have said it wouldn't sell. It's like Black Panther, I loved that film on a number of levels, as a black person, but it was like really positive, but also the idea that this forward thinking technology, it wasn't Africa depicted in a poor way. It was like forward thinking, and there was a young a girl using technology there, which was like, of course, why not? Like, this is exactly what the future is. It's what now should be. So I just think the power of film, especially because it's storytelling, it's people, it's building of plots and stuff, there's like a lot of potential there for changing the world. I know it's a bit strong, but I think it's true. It'd be interesting to see whether NASA now, after Hidden Figures, has now got more black women or people of colour applying to work there. Do you know what I mean? So the power of popular culture is huge. So
that's a very positive way. This film can change the world, actually change the world we live in. But so can problem solving.
Yes, and so we can now showcase the reality of maths as well. Yes. Do you want to remind us of what the problem was, Bobby?
Yes. So we had a basketball team, 5 players, and we were given the shoe sizes or stats about it, and we were told that the mode is 12, the median is 11, and the mean is 10. And again, normally we would have recommended writing these things down because it's quite hard to keep it in your head. So the question was, what could the shoe sizes be?
So before we do any maths, the question to ask ourselves is, how did you feel when you first saw the question?
So, I think I'd seen puzzles like this, especially something called an organization called Enrich. And they're part of the Cambridge University. They make sort of like stretching puzzles for young learners. So I thought, I've seen problems like this where it's not a direct, it's not going to be one answer.
I think because a lot of the time there's loads of questions out there like, here are the numbers, here are the 5 shoe sizes, what is the mode, what is the mean, what is the medium. This is like actually thinking backwards, and I love these questions, but you do have to think quite carefully about where do you start, what did you do next, what did you do next. And so did it make sense to you?
I think with this one, what I like about the question is it doesn't seem too complex in the sense of it might be a tricky question itself, but it's quite like it's only like 30 words, the question, 40 words. It's quite a compact little question.
But the key thing is, if you don't know what the mode is, which is the most the data that comes up the most, if you don't know what the median is, that's if you put all the information, all the data in order and then go to the middle value, or you don't know how to work out the mean where you add them all together and then divide by how many numbers you have. If you don't know that information, it's going to be there's no way you're going to be able to do this.
That's a great question because in fact, so what are the topics in this question? It is essentially statistics, mean, median, mode, average. And average is, again, for people that are wanting a bit of clarity, average actually includes mode, median, and mean. And so technically, if someone says, what's the average? Most people actually are thinking of the mean.
Yes.
So you add them all up, divide it by how many there are. But mode and median are averages.
and also it's worth kind of thinking about that when you are given the value by different organizations like newspapers, because you're wanting to know what one are they actually using, because technically they could use any. But yeah, the most common one that is used is the mean. And so I suppose it's now about working out like the parts to it. So we've worked out what math it is, what kind of math topic it is. I've done the general questions around it. And so what can we actually derive?
Susan, so how did you work through this problem?
Okay, so what I did was I strapped in and I was like, right, what do I know and what can I put in? So obviously, as I drew a diagram. I drew a diagram of 5 empty boxes, and I was like, right, okay, what can I put in? And from the information that I was given, the median is the middle value, so I put 11 in the middle. And then because mode is the most common and there's only 5 numbers, the mode has to come up twice. The frequency of it has to be twice. So 12 I put as the last 2 numbers.
Yes.
Yeah. And then the first 2 parts could be anything that takes our value of 35. If you add 11, 12 and 12 together, it gives you 35. To find the mean, the mean is the sum of all the numbers divided by 5, because there's only 5 shoe sizes. So that's 50.
Yeah.
Because so 50 is your total if you add them all together.
Yeah.
So I then was like, right, we know 35. So that means the first 2 values have to add up to 15. And you could have 7 and 8 or 6 and 9 or 5 and 10 to keep it all whole numbers. That's kind of what I sort of did. Because after 10, it takes you over 11.
Yes, although technically you could do 13 and 2. That's some weird. Could you do 13 and 2? Yeah, weird shoe size. Oh no, it would switch the. Yes.
So what's
switch the? So would a 13 and 2 still work? Because if you just no, because then it switches the median, doesn't it?
So I was like the 11 has to be in the middle, and then either side is what you're kind of working with. So
it's a nice problem actually, because again you could, by changing, I guess this comes into the bits of how could the question get changed. By changing some of the parameters like the median, it would change, because I guess for us the most important bit initially was the mean. That's how you worked out what the balance must add up to.
Yeah, so work out the balance, but then the other parts, the mode and the median, so 11 being in the middle and then the mode, meaning is 2 values, has an impact on what it kind of looks like. There's more than one answer, right? That's kind of the key thing.
There are more than one, yeah.
How did you do it?
So pretty much the same way as you. I didn't draw a diagram. I should. I need to learn. I think I literally said, 11's in the middle, and I put comma, no boxes, so comma. Then the other 2, you'd expect them to be 12 as a mode, 15 left over out of 50, and then now try and jig about to get 2 numbers that add up to 15, but they can't be the same.
Okay. Yeah. And so, as you say, to extend it, another thing we quite like to do is to think, right, once we've got our solution, which for this one, there's a few solutions here. Once we've got that, what can we do to extend it? And like, if we were to add another person or to change the mean, what impact would that have on the numbers as well? There's a lot of food for thought there. So I thought I'd made a mistake because there's more than one answer.
No, there is. Yeah, it's more than one. Although I'd temporarily forgotten that the median is in the middle. So let's go for 13 and 2, 14 and 1.
Oh, did you go that far? Yeah.
But then I forgot, the median is 11, so that's got to stay in the middle. As soon as you add another number, then 11 shifts along to being the second number.
Right. So we'd love to hear what your solutions were. If anyone did it differently, it'd be great if you could share your solutions on Twitter. Post them on Twitter, that'd be amazing. And so now we've done our problem. Bobby, going to hit us up with some maths fact.
A maths fact. And today's going to be stats related. In maths, when you draw a circle and it represents data. So imagine like we did a little survey. What are maths appeals fans' favourite packet of crisps, flavour-wise? So they might like cheese and onion, ready salted, prawn cocktail.
Yeah.
Okay, yeah, I see. Prawn cocktail, definitely. So you did a pie. What's the type of chart? I'm not good at this game, am I? What's the type of chart that you do? I might give you the answer.
A crisp chart. No, you do a pie chart. You do a pie chart. Yeah.
A pie chart. So imagine we went to La France and we did the same question. They don't call it pie chart. They actually call it another type of word. So name me some cheeses. This sounds like this is the Master Wheel podcast, not the cheese podcast, by the way.
Cheddar? No.
Cheddar, no.
Halloumi, my favourite.
Halloumi, hello.
No. Halloumi. Oh, French. Brie?
Brie, no. Try another cheese.
French. Camembert.
Camembert. It's called a camembert chart.
It's
in
called,
France.
so they call
the
it...
pie chart.
They call it a camembert chart.
Because it looks like a
Wow.
slice. You know, if you like a slice of a pie chart,
Yeah.
it's like a piece of cheese.
I suppose camembert is round as well. That's hilarious.
Yeah.
So would you say just le camembert, or would you say le camembert chart?
I guess camembert chart, like a pie chart.
Sure,
Yeah, like we
okay.
use pie. Like in France, they probably like, guess what they call it in England? You know that thing that you have steak and kidney? Yeah? Steak and kidney pie? Yeah? They call it a pie chart. You know, the French version of Masterfield is laughing.
At us, okay. Well, this is what's great about this. This is for everybody. We'd love to hear, wherever you're from, we'd love to hear what you call a pie chart. Watch this space.
That's cool.
So, if you want to send us more maths facts, we'd love to hear from you, or any maths problems, please get in touch with us at Maths Appeal on Twitter and on Instagram.
Obviously, you can email us as usual, mathsappeal1, that's the number 1, at gmail.com.
And thank you so much for listening and for downloading this episode. It'd be great if you could give us a 5-star rating. And please share the Maths Appeal love with your friends and family. We want everyone to love maths.
So you've been listening to Maths Appeal with me, Bobby Seagull, and Susan Okereke.
And the music was composed by Kelly Okereke, the image designed by Calix Davis, and the producer is the wonderful Jenny Nelson. And we'll see you in episode 6 for more maths problems solved together.